Welcome back, Mathies. We are going to finish our 1.3 notes, which means we're going to do problems 5, 6, and 7 on page 17 of your student journal. To do this, you need your student journal out. You also have to have a graphing calculator for this one. So please get your graphing calculator out and let's get to work. What we're basically doing, we're going to go into the details of this later, but we're learning how to crunch big data. So when you get out into the workforce someday and you have to make sense of a bunch of data, how do you use that data to make predictions about the world and to make better informed decisions? We're going to use our graphing calculator and we're going to get started. So to do that, there's a few things that you have to do with the calculator. Thing number one, go to y equals. If there was anything in any of these, you need to clear that out. So I've got numbers that I just put into y1. So I'm going to go up, clear, and that's gone. Second, you probably don't have this plot 1 bolded. And what you need to know is that anytime you want to do statistical analysis, you need that to be bolded. So we're going to go up to plot 1, hit enter. Cool. That's going to allow us to get a picture like this to show up on a graph in a little bit. The next thing we need is something called diagnostics on. Whenever you're doing data crunching, we want to have that on. That's in our catalog. You can see that button down here. So we're going to hit second catalog because the catalog's yellow and the second button is yellow. So hit second catalog, and all of these things are just in alphabetical order. So if we want diagnostics on, we just have to scroll down. Go to diagnostics on, hit enter. You have to hit enter one more time. When it says done, now our diagnostics are on. That is going to allow us to find an equation of best fit later. It's also going to allow us to find the correlation coefficient. You can only do that if your diagnostics are on. All right, let's get to work and let's actually do problem number 5. So we want to get these points into a scatter plot. So to do that, we're going to hit Stat button, and we're going to go Edit. And this is going to be our list. Now, what's going to sometimes happen is you're going to already have numbers in your lists, and you don't want that. So if you have numbers on your lists, all you have to do is use your up and down arrows to get up to like L2 there, and then I just go clear, enter. Now it's gone. And I'll hit over here, go up there. I'm going to clear that one out, clear, enter. So if you have anything in there, that's how you get rid of it. Okay, so what do we want in there? Well, we want these 5 points in there. So let's quick write them down real quick. Let's see, this is the point 1, 5. 1, 5. This is 2, 2. 3, 1. This is 5, 2. And 5, 5? Yep. Okay, so those are what's going to go in there. So we're going to put those in one at a time. So first I'm going to put 1, 5 in there. So it'll go 1, enter, then I'll go over here, 5. So list 1 will be all the x coordinates. List 2 will be the y coordinates that go with it. So over here, 2, 2, 2, enter, 2, enter. Over here, 3, 1, 3, enter, 1, enter. 5, 2, so 5, enter, over, 2, enter. Good. And then 5, 5, 5, enter, 5, enter. So now I have those 5 points in there, and because I have this plot on, if I hit graph, it replicates what I have right here. If that plot was on, it wouldn't have worked like that. So now we have that. And now we can start doing analysis on this. The first thing I want to do is I want to find the equation of the line of best fit and the correlation coefficient. So I'm going to do this and this right now. To do those, we hit the Stat button, calculate, and it told us to use linear regression. So they want us to use linear regression. So that's the 4th one. Go down there, enter, and you have to hit enter one more time. Very good. All right, so we've got all this stuff on here. How do we make sense of this? First of all, your R value is the correlation coefficient. Okay, so we're going to say R equals, let's go negative 0.07. I'm going to go to 3 decimal places, so 0.07, that would round to a 5. I would like you to go to 3 decimal places as well whenever you do these. All right, in the equation of the line of best fit. So it is an equation of a line, so y equals slope x plus the y-intercept, and then it tells you what those things are. So let's say that y equals, our a value is negative 0.07. It will go negative 0.078. Again, I'm going to go to 3 decimal places, and I want you to do the same. X, and then plus b. Our b value is 3.25, so plus 3.25. So we have a correlation coefficient and an equation of a line of best fit. I think we should talk about what those things are first. The correlation coefficient, why don't you take a little note up here? The correlation coefficient is basically a measure of how good your line is. So it measures how good your equation is. And then the next note you would want to take is that close to 1 or negative 1 is awesome. Close to 0, 0 is bad. So let's now try to get this line on here so we can take a look at it. So get your calculator back in your hand, and what we want to do now is I want to graph this line. I want to get it to show up right here. And instead of copying this into here, I'm going to get it a different way, because remember, I did round to 3 decimals right there, so it's not exact. I want to get the exact regression line in there. So what I'm going to do is I'm going to go to VARS, and you're going to do the same. VARS, you're going to go down to statistics, and you're going to go over to equation. Do you see how that put the equation right in there? All right. So now I have that, and watch what's going to happen if I graph it now. So the calculator has decided, doing what it does, that this is the best prediction line for this data. When I look at this and I'm like, this line's doing a terrible job of predicting the data. If anything, I think the data looks more like this shape, not this at all. So I'm thinking this is a really bad correlation coefficient. It's just a bad equation. So let's look at my R value. My R value is negative 0.075. So that's really close to 0. That's bad, which actually makes me feel good, because when I looked at this, I'm like, wow, that looks really bad, and this R value confirms it. That is a bad regression line. So let's see here. Find and interpret the correlation coefficient. So we found it. Let's interpret it. This equation does a bad job at predicting data points. And I think I'm just going to stop there on number 5, because we've done everything they've asked. We found the equation, we found the correlation coefficient, and we've decided this one's not very good. Let's go on to number 6, and let's just do all the same stuff and see what happens. So here I go, and you're going to do the same. All right, so I'm going to clear that out. All right, so I'm going to go back up to y equals. I'm going to clear that out. I'm going to keep the plot on, though, because I still want to do statistical analysis. I'm going to go over to stats. I'm going to go back to edit to get one of these. I don't want those points anymore, so I'm going to go clear them out. Clear them out. And now I'm going to put in the new points. All right, so this is the point 0, 25. So let's get at it. I'm going to see if I can get this on here in a good spot. If I move that over a little. Yeah, there we go. Okay, so we've got 0, 25. 0, enter, 25. Enter, okay? The next point is 120. 120. The next point is 215. And our next point is 3. We're going to have to make a guess here. To me, it looks like 3, maybe 19. And then finally 4, 5. I made a mistake, didn't I? This is the point 39, not 319. Don't make mistakes. It'll throw everything off. So I fixed that, and that's why it's just a good job to always double check. So I'm going to double check. Yep. Okay, I like the data now. So now I have to go back and do the things that I did before. Because my plot is on, it will show this. However, it's a 10 by 10, so it's not showing it very well. Let's see. So I'm going to go to my window, and I don't need it to go from -10 to 10. I need it to go from like 0 to 10. So I'm going to go 0 to 10. And I don't need it to go from -10 to 10. I need it to go from like 0 up to at least 30. I'll put 40. 0 to 40. Let's take a look at it now. Yay, that looks a lot better. Okay, so now I want to start analyzing this. So I'm going to get my correlation coefficient and my equation of the line by going to Stat, Calculate, down to Linear Regression. Notice we're going a lot faster this time, just doing those same steps. Okay, here we go. Our R value is -0.99, and that'll actually round to a 9. All right, let me move this. R equals -0.999. Then put this back over here. Our equation is going to be y equals, it's going to be a, so y equals -5.1 x plus b, so plus 25. So I'm going to write that down here. So I'll write y equals -5.1 x plus 25. All right, so let's interpret this correlation coefficient. So -0.999. That's really close to -1. That means that this is an awesome line. This equation right here is doing a really good job at predicting these data points. So we're going to say that this equation is doing a great job. I should put because R is close to -1. And then I should have also over here, I should have probably said because R is close to 0. Why don't you go back and fix that? Yay. All right, we have technically answered this question that they asked right here, but I'm telling you that on a quiz or test, we're going to go one step further. So what we want to be able to do is now that we have our line to make predictions, we want to actually be able to make a prediction. So for example, what if we had a x value of 3.5, what would be the output? We predict it would probably be somewhere in there, but I don't like saying the word somewhere in there. I want to know exactly where the best prediction would be. So we're now going to learn how to use this data to actually do something. Because I think you'd have to agree, so far we did a lot of math, but we haven't actually used it to solve a practical real world problem. So let's look at what it might look like to use this data in a meaningful way. So what I want to do now is I want to actually see this line on top of here. So I'm going to go back to y equals, because I want to put that equation right here. So I got to start by going to y equals. Then I push vars. Again, we did this all last time. Statistics over to equation. Now we've got the equation. We put that right here, and it gets the line. Now the next step is actually the answer to the question, why would you want to use this in real life? Suppose I wanted to make a prediction of what the output would be at 3.5. So if the function here had an input of 3.5, what do we predict the output would be? Here's what you do. You want to calculate that. And if you see right here, this says calculate above trace. So let's go second, calculate. We want to calculate a value. So hit enter. If we do an input of 3.5, so they're like, what do you want us to calculate? I want to calculate what would the output be at 3.5. So if I put an input of 3.5, it would output 7.15. This is 5, this is 10. Yeah, this is right around that area. Now, if we didn't have this regression line, we probably would have said, maybe I'll guess somewhere between 7 and 8. But by crunching the numbers, we can actually make a little bit better guess. And we could say, we predict it would be 7.15. So this was not part of the question they asked up there. But these are going to be the kind of things that you also will be asked to do on quizzes and tests, and that is how you would do it. You get that equation in there, like this, and then you go second, calculate, value, you put in the input, and it spits out an output. So with that said, I want you to try to do number 7 on your own right here, and I'm going to tell you that if you do it right, you're going to get an R value of 0.99, and you're going to get an equation of 0.55x plus 0.82. So what I want you to do is I want you to repeat the steps here until you get these numbers. And if you get that, then you can have a lot of confidence to know that if you go to do your homework, you're going to be able to do it. Good luck, everyone.